Hello everyone, welcome to the webinar, Entity Resolution in Action. My name is Yogesh. I'm the founder and CEO of Inferyx. I carry a strong passion for building technology products and solutions. I have almost 18 years of experience working in the field of data management and analytics, and have been leading architecture and engineering for various Fortune 500 companies like Citigroup, Wyndham Hotels, UPS, and few others. I come from a diverse domain experience from banking, healthcare, hospitality, transportation, and few other industries. Just to give us some background about Inferyx. So Inferyx is basically, we are a global analytics company, which is, and we are helping enterprises to build AI applications using our low-code data management platform. Our mission is to empower enterprise to build end-to-end AI applications using our data and analytics platform. So here is the agenda for today. We are going to talk about what is entity resolution. Then we are going to talk about the architecture of entity resolution, and then look at as an example. Followed by that, we'll look at some real world challenges and then have a quick demo of the entity resolution. And finally, then we can take some question and answers. So there is a quick poll. We are going to open the poll. If you guys can quickly answer the poll before we get started, would appreciate that. I'll take a quick pause for like few seconds and then we can get started. Okay, so I see we already have the responses coming in. Thank you very much for that. So entity resolution. So what is exactly entity resolution and why it is needed, where it is applied? Let's talk about that. So entity resolution is a process of determining and linking the real world entities through data and their relationships. So imagine, just to take up an example to understand this better, let's take an example of customers. So you may be receiving customer data from various source systems, right? Like maybe more than one, if it's a large organization or if it's a global organization. What could end up happening is you can receive the same customer twice or maybe multiple times from various systems. It could also happen within the same system itself. This customer can re-register itself, not because it is done intentionally, but maybe because of a system glitch, or maybe there is a loophole in the system, or maybe there is some kind of fraud going on, which can end up creating the same customer multiple times. So what would happen in that scenario is like you would not have a complete 360 degree of the customer and its attributes like demographics, the activities that the customer is performing. And hence any kind of analytics you try to run on this kind of data is going to be, suboptimal. To take up an example, we will talk about a marketing campaign that a company would typically run for customer analytics. So what really happens is like, let's say you want to send a new product is getting launched and you want to send the, the flyers or, some kind of campaign emails to these people. And then if the same customer is recorded like multiple times in the database, the marketing team is going to end up sending that email more than once to the end customer. This will basically piss off the customer because the customer is receiving the same email multiple times, and hence it's really a wastage of resources, and also you are like kind of having a bad impression on the customer. That's like the first use case. If I talk from a fraud detection perspective, imagine that it's a bank and you are trying to do like a fraud detection system on, or trying to detect the fraud on the customer activity. So unless you have a complete end-to-end picture about a customer of all his or her transactions, it will be very difficult to really do justice and find patterns in the fraud. So normally, in fact, to be on the contrary, the customer would try to create, if the customer is like a fraudster, then the customer would try to create multiple accounts by giving subtle differences in addresses, phone numbers, or maybe there's name change, some characters are flipped here and there. And this will end up creating multiple records of the same customer, and the customer now can operate under multiple accounts. So each account will have its own activity, and then finally, I don't think so that we'll be able to get a 360 degree view of the customer and his activities. And maybe in parts there you don't see anything fraudulent out there, but when you have the sum of the parts, which is like having all the transactions seen at once across these two entities, which is actually one entity, you would see that some kind of fraud pattern is coming up. So to basically, so these are some of the use cases. Then obviously you can use for knowledge graphs, which is about investigating a customer, or recommending products, the new product launches I was talking about, or network analysis, where you want to see a social connections and leverage a relationship to find the influences in a graph, or maybe look for network rings, etc. So graph plays a huge role when it comes to entity resolution, and that's one of the technology that we're using in the platform, in our platform. And in fact, even if you're building something custom, you should really consider using graph technology, because entity resolution is all about resolving entities through relationships, and graph just makes it easy, both in terms of scale and the way it executes the queries. Let's talk about architecture now. So for example, imagine that there are 3 different sources from where you're receiving the data. The first step you really want to do is, you can obviously, clean up the data in the beginning. Maybe there are some records which you are not interested to resolve. You can filter those out. So that way the noise is out of the data, and then you have a very focused data set that to focus upon, okay? The first step you would really do, like, apply a blocking condition. Now, this is an optional step. It just depends upon the scenario if you are coming across. So the scenario would be that, imagine that you are having customer data from, it's a global company, and you have customer data coming from multiple regions, right? From North America, from Europe, and from Asia, let's say. Now, you may be, your business may be okay that, that they may be okay that that maybe you do not want to compare records from North America to with Europe, and European data to or vice versa, right? So that could be one of the business rules that you want to block intentionally, right? The other reason could be you have large volumes of data, let's say millions of records. If you're dealing with hundreds and thousands, then I don't think so it's a big deal. You can still comparing each record to every other record and still finish the process in a couple of hours. But if you're dealing with like millions of records, you can imagine that if you're comparing million to another million set, it's like million times million, or 100 million times 100 million, if it's a 100 million record problem. So that can take a very, very long time, maybe a few days to resolve all the entities, and then you won't be efficiently able to process on a daily basis and apply the data for analytics. So to avoid that, what you can do is, if there is no business rule in place to eliminate this issue, then if you are aware that, let's say 5% of your data or 5% of your customers, they haven't really transitioned from one region to another region, then you know that there is a very less chance for the same person to be present between region A to region B to region C, right? So there's no point of comparing customers from region A to region B if your transition is less than 5%. I'm just giving an example. This 5% could be 10% for someone, and it could be like 2% for some other business unit. So this will allow you to eliminate comparing each record to every other record, and basically boil down the problem into smaller pieces. So if this was a 100 million record data set, so what would happen is, out of 100 million, let's say 60 million belongs to North America, and 20 belongs to Europe, and 20 belongs to Asia. So in that case, you are not comparing the 60 million to the whole 100 million. You are only comparing 60 million within the 60 million, and then 20 within 20, and the rest 20 within the final 20. So that way, the number of comparisons that you're performing are much less. So blocking is really your trump card. If there is a business rule, you're lucky. If there is no business rule, and if you're dealing with a large volume of data, then you can use this strategy, to compare, to eliminate basically comparison of, n times n problem. Once you have blocked the data, which means you have kind of segregated the data into pieces, then you can individually take all the records within that block and compare among each other. And then this is called a pairwise comparison. Now, what can you compare? You can really compare like one or more attributes. It doesn't have to be a single attribute. It doesn't have to be a very basic logic like checking for the names are exact match or not. Or it doesn't have to be even a fuzzy logic. It can be, in fact, we can use something more sophisticated mathematical algorithms like Gyro-Winkler or Jaccard or Levenstein distance. These are all similarity functions where you provide 2 strings of data, and then it will respond you back with a score between 0 and 100. It's like it's just telling you the percentage of match between the 2 strings. This could be names, this could be phone numbers, this could be addresses, just depends, right? So you can use one of these functions. These functions are available out of box on Inferyx platform. And then once you configure it and execute it, it's going to compute all the scores. Once the similarity scores are computed, then comes the final step, which is a clustering. So imagine, just take a small example, like let's say you're trying to compare A, B, and C. There are 3 customers, and now you are able to somehow determine that A is equal to B because of the name or the address. There is a more than 50% similarity, and assuming that 50% is your cutoff, you're going to basically equate A and B, saying that they're the same entity. Similarly, you're going to compare A and C, but you may not find a match out there. Then you'll compare B and C, and you would find probably, let's say, a good comparison point, right? Like, let's say the score is more than 50%. So what we are trying to say is, like, if A is equal to B and B is equal to C, that means A, B, and C are actually the same customers, or they are the same entities. Okay. Now the entity would be customer address. I'm just taking an example here. So this is how the clustering takes place. So if I start with 10 records, and let's say I'm able to, the first four kind of fall into the same, the first four, let's say they fall into the same bucket, and then the next two and the next two, like 4 and 4, and maybe, like, just total it to 10, let's say. So it can end up into like 3 or 4 cluster, depending upon how much duplication is there in your data. Okay. And then finally, what gets into an individual cluster, those are all the linked entities. So if a cluster has, let's say, it ends up having a couple of records, like 4 or 5 records, and all those 4 or 5 records are linked into one record. So that's basically the clustering and linking process. Okay. Feel free to, by the way, put up your questions in the chat box. We will take them at the end. I just saw like someone was trying to ping me. I'm sorry, but let's just take all the questions at the end. Okay. So continuing on this, let's talk about an example here. I have taken a very simple example. I have like 9 records here coming from 2 different sources, 5 from first source and 4 from the next source. And they have a mix of data. Some data is coming. I mean, if you look at these records, it's a combination of 2 countries, US and Canada, right? Now, there is a high probability that, the people, the names, it could be the same person living both in US and Canada, but we are making an assumption here that as per our business rule, it's okay to partition the data and compare within the partitions. So the first step, what we do is we kind of partition this data. So as you see, there are 4 records going into the USA bucket, 4 records going into the Canada bucket. Now there is one record, which is record number 104, which you can see here, Angie Jordan. We don't have his phone number, we don't have the address, his or her, and we don't even have the country. So we cannot really bucket it into either of the bucket, and then finally it will end up having its own entity ID. So if you see in the result on the target side, 104 ends up having its own entity ID, and that's pretty much it. It's like it's the only entity that is in its own cluster, and it ends up being like a unique entity. Now there is a high possibility that 104 may be actually some same person like 102 or 105, but since there is a lack of information here, this is like a deficiency, and we are not able to resolve it to any other entity. So these are like one of the, I would say, missing data issue. There are many other challenges that you can come across while doing entity resolution, but this is one of the very common problem you will face. So taking up an example here, we'll take the first example, which is green in color, Angelica Jordan, ID number 101, and the phone and the address, and it belongs to USA. Similarly, if you see Andrew Jordan belongs to the same country, so they get bucketed into the USA. And then finally, what we do is we do a comparison of every record, as I said. So we are comparing, let's say, 101 and 103. Now we found the there are 2 scores we are computing here. Now there's no limit of how many scores you want to calculate. It's just your design and implementation choice. I mean, so this is obviously done in conjunction with the business people, what their comfort level is. So if you see here, like we can create 2 groups of matching criteria. First group will contain name and phone number, which means we are combining the 2 attributes and comparing them together. And then we are taking address and phone separately. Okay, we're totally ignoring name in that case. So in this example that we are talking about, we are comparing Angelica Jordan and Andrew Jordan. So if you see, the first name is not matching, but this last name is kind of matching. So there is at least 50% or a little bit more than that, between 50 and 60% match. We apply like a 50% weight on each of these. So if I have name and phone, I'm going to compare name to name, phone to phone between the 2 records. And then whatever score I get, I'm going to do a weighted sum on it. I'm putting right now 50% weight. Again, this is just an example. You can choose whatever makes sense for your business. And then accordingly, you will compute a final score. So once I have the score available, then I go to score 2, which is second criteria, which is address and phone. So if you see in this case for 101 and 103, the address and phone are an exact match, and hence the score is 1 in score table. So this 1 represents that there's an exact match. And then what we do is the logic that we have applied here is like to choose whichever is higher. So obviously higher is 1 as compared to 0.76. And hence we kind of conclude that 101 and 103 is the same entity. And then we go to the next one. So we keep doing this until we derive all the entities and their relationship scores. Once that is determined, then finally what happens is, then we have to do the clustering process, right? Now it's time. So we have found relationships. Now on the basis of these relationships, now we are going to create clusters out of it. So if you see here, 101 and 103 is kind of equating to each other. 102 is equating to 105. 102 is equating to 103. Hence, 101, 102, and 103 and 105, they are all kind of linked to each other and they all belong to the same cluster. So there are 3 records in the first cluster. In fact, 4, 101, 102, 103, 105. So there are 4 records. Similarly, we do it for the ones which are yellow in color. You might see, I just want to highlight one more other thing. A downside of, I would say, let's assume that you had a customer who was living in USA and then he or she moved to Canada. And since we are bucketing, obviously we are not comparing. And I do have an example here to represent the same. Example number 101 and 109. If you see, the address and the phone number is an exact match. But because of the data quality issue, probably, maybe this is not an example where the person has moved really, or maybe he moved and the address was not updated. See, these are the discrepancies or the nuances in the data. Because of which we are not comparing, because they fall in different countries and hence they become different entities. So if you see, 109 is an entity by itself in its own cluster. It was quite possible that 101 and 109 may be the same person, but since we made a decision to block, this is like one of the limitations that we are going to run into. But again, if you look in the entirety of the data, these exceptions or nuances are going to be a fraction of your total data. It could be less than 5%, and then obviously you have to strike a balance between performance and accuracy, right? Okay. So let's talk about some challenges that one can come across while building an entity resolution system. And these are the things you can say challenges or to be considered when you're choosing an entity resolution product, right? Or if you're building one by yourself. I think scalability is a huge aspect. I don't think so that people who are dealing with 10,000, 15,000 records are really dealing with entity resolution problem, because if you have just few thousand records, I'm pretty sure you're not dealing with multiple systems, probably like just one system, and then you should not have this issue at all. The issue really comes when you have multiple systems, and when you have multiple systems, obviously you're talking about millions of records, and that's where the problem really starts. So scalability is a huge problem here. If you're not using the right technology or the right product, it can be very time-consuming process. So using the right technology, like a distributed computing system, like for example, like a graph technology like Spark or Neo4j for that instance, can really help you resolve this, because you can distribute your workload across machines and then get it resolved in parallel. Multilingual data is another aspect of it, where if you're a global company, you may be receiving data from multiple regions, and some of the regional data can be in a different language, and then comparing is going to be a nightmare. So this is something that you might have to look into. Data quality issues, as we saw an example before, where like you may have discrepancies in the data, where the address belongs to North America, but the country is Canada. So this is like a data quality issue. There could be other issues too, but this is just one of them to cite. Missing data elements is something where, if you remember the record number 104, there was no name, or a name was available, but the address and the phone was missing, and the country was missing as well. So missing data elements can represent some noise in your data, and then they don't get really resolved in the right way. In fact, the data can also change over time. So today, an entity may come in today, and it might get resolved to cluster 1, let's say. And then tomorrow, there are some changes in the same record, and now the same customer may go to like cluster number 2. It may get resolved to somebody else. Now you just have to deal with like all the analysis that you have done until today was with the perspective that this customer belongs to cluster 1, and you might have created offers accordingly, or like done your fraud analytics accordingly. But now if there is an update to the information, now you have to kind of shift the customer. So you can have something like, if you're building a warehouse, then maybe you can have a slowly changing dimensions where the customer is kind of moving between clusters. That's one option, but you might have to see what happens to the integrity of the information, right? There could be different data format problems too. So if you're dealing with structured data, no big deal. But if you're dealing with structured and unstructured, because some of the relationship information might be in unstructured data, which you want to leverage. So just make sure that you choose a technology and a platform that can handle a variety of data, like I mean, in terms of the the structure, like structure and unstructured both, and that then can really be leveraged as a part of your ER process. Okay, so that brings us to the end of the slides. Now we can go to the demo, and once the demo is over, then we can do a Q&A. Okay, but before we start the demo, I would like you guys to, I'll open up the poll again. There is another question we have for you guys. And here you go. I just started the poll. If you can quickly respond, then we can move to the demo as the next step. Excellent. Okay, so let's continue to the demo now. So as you see, like so our platform, basically this is the Inferyx Analytics Platform. As I said, just a quick introduction, it allows you to do an end-to-end data management and analytic function. You can build any AI application or a data application without writing any line of code. Okay, it's a fully configurable thing. There are 15 modules available, very comprehensive platform, and it's completely technology agnostic. So if you like to run this platform against, let's say you can have like multiple applications on the platform. One of those applications could be running on a traditional database, which is like Oracle, and another application could be running on a big data cluster, and third maybe a graph technology application. So they could be completely disparate or heterogeneous in nature. Now I'm just going to log into this interface now. This is the web interface of our platform. As I land, you will see there are around like 12 to 15 modules that I was talking about. Today, we are going to focus especially on the entity resolution, and then subsequently in the upcoming webinars, we are going to take up other modules, okay? So let's go to data discovery. This allows you to search for the data that you're looking for. I'm going to start with, we have a table called ER sample. ER sample. This is a table we have created for the entity resolution demo. This is a table in MySQL. It has 5 columns at this point. There's a primary key called ID. There is a name, telephone, address, and country. Now let's look at some sample data for the same. So there are 9 records in this table right now. So we are not trying to do a scalability test here. But just to be very honest, everything is running on Spark right now with data in the MySQL. So if we have to really test this platform out against millions of records, no big deal. We have already tested it against 50 to 100 million records, and we're able to process the entity resolution process in like few hours. So scalability is not a concern here. I just want you guys to focus on the example right now and the entity resolution process as a process. So these are the same 9 records that we were looking into the deck. Nothing different about it. You can quickly, if you want to see what is the distribution of the data, you can look at the same here. We see that we have USA, Canada. I think there may be a space or something in the data, hence it is kind of creating multiple times. So let's do one thing. Let's quickly get into the entity resolution now. So the first step of entity resolution process in our platform is like you have to configure an entity, right? What is an entity? It's a metadata driven platform. So everything has to be defined. It's a definition driven platform, I would say. So in this case, we are using person. Person is like very synonymous to like, I would say customer, because a person could be customer, a person could be an employee, and the same person could be an employee and customer, right? At the same time, you could buy things from the same company that is working. So if you see here, what we have done is we are kind of giving the basic information. Then we are giving what is the source, where is the data coming from. Then you just have to configure the primary key. This is going to allow you to say what is the unique column in the data, and then what are the detailed attributes that you want to focus upon while performing the entity resolution process. I'm leaving some attributes blank here, like parent entity, child entity. So what they really allow you to do is, let's say if my entity resolution was happening for account. So for an account, the parent is a customer, right? So I'll choose customer as a parent, and whatever is the key that is defined. And then from a child's perspective, if I'm looking at an account as an entity, that means transaction could be one of the entity, or a sub account could be a child of account. And that becomes like a child information. If you provide this information, then we can do some further intelligent processing. You can connect to that data and drill up and down. Okay, but this is at this point is just the metadata. One other concept I want to introduce to you is the exclusion list. So exclusion list is basically what? Well, imagine that you are trying to compare names, and the names may be like Mr. Andrew, and another name can be just Andrew Jordan. There's no Mr. in the front. So you don't want to really compare Mr. because Andrew Jordan and Mr. Andrew Jordan are really the same people, assuming that they are of the same gender, like male. So you want to really strip off this Mr. MR as a character, and there could be dots in it, there could be spaces, any kind of special characters, right? So I'll show you how to define exclusion list on the platform. This is the name exclusion list. If you see here, I can say like, okay, I want to exclude any special characters. At this point, you're not really associating the list to the data. You're just creating a list which can be reused. So again, as I said, it's a metadata driven platform. So you can keep building things and reusing it. That's the whole purpose of the platform. So here I can define as many as words I want, the keywords, and I can say whether they should be in capital, they should be, or the case should be ignored. Should they be in the beginning, in the center, at the end, or anywhere in the situation, and then you can also look for entire word match. Okay, so we kind of create a regular expression and remove all this junk out of your data before the comparison. Let's look at the entity resolution definition itself now. Okay, so here first I'm just going to put some basic information. Once this information is created, then we can point out like what is the source of it. So here if I have selected like ER sample is the same source I'm selecting on which I'm trying to perform the entity resolution, right? This was the data that we were looking at some time back. And then I'm choosing like which entity type, which is person in this case. And then if you have a business date column, which is typically available in any kind of data, you can point to that so that we can do reporting, some kind of reporting in a downstream process. Okay. If you like to filter any data before we start the entity resolution process, that is possible. Here you can define as many as filters you want. And then this filter, basically we are saying that wherever there is no country available, please ignore that data, because there's no point of resolving or comparing. You're just going to waste the cycles, right? Because we already know that that entity is going to end up being into one cluster anyways, right? Then we choose the blocking condition. Blocking condition columns can be one or more. Here I'm choosing country as a blocking condition as per our example. But if you want to make it more unique, like let's say you want to do city, I would recommend that you combine state and city because a city can repeat across multiple states. So here, and then the next thing is really defining the matching groups. Now you can have as many as matching groups possible. Here I'm having two matching groups, one from a name perspective, another from address. Going back to our example in the slide, we compared name and phone, and then we compared address and phone, right, as a combination. So you can pick the column of interest, then you can choose which function you want to apply to this. And then also you can choose the exclusion list. So in case of name, I'm going to choose a name exclusion list. And then once that is done, then you can put a weight here. So what is going to happen is we are going to compare the name to every other record on the name column and then apply the Levenstein function on it. This will produce a score between 0 and 1. We'll multiply that score with the weight, which is 0.5. Then again, for telephone, we'll repeat the same process. Once we get the two scores, weighted scores, then we are going to sum it up. So this is like a weighted sum kind of thing, And then we'll compare the final score to the threshold, which is 0.5, like 50%. So if there is a more than 50% of match, then these two records are going to be linked together or they'll be not linked, right? As simple as that. And again, this is an OR condition. So if the name doesn't match and if there is an address match, it's going to still pick it up. If you remember the example that we were looking at, the one which was in green, we had two scores available, 0.73 and 1. And 1 was corresponding to the address match. And since it was a 100% match, we kind of considered that these two entities, 101 and I believe 103, are the same entities. Okay. Once all this is defined, you can execute the rule. And then finally, we can look at the results. I'm going to go to the results area now. Okay. Once you get to the result page, the first thing is going to show you how many entities were scanned and how many unique entities we were able to boil down to. So if you see, there were 9 entities that we were looking at, including the duplicates, obviously. And then finally, after the process ran, we were able to link and remove 5 of them. So there were 4 unique entities left behind. And you can see the plot of it right at the bottom. So there was one entity which contains 4 of them we kind of grouped into one cluster. You can right click and get into the detail of this. This graph can be very cluttered if you have like millions of entities and they're all unique. But assuming that if you see any spike anywhere, that means a lot of entities may have got grouped into one, and you may want to just make it, double check it, like has the algorithm done its job correctly, right? So it's not really for not much so for reporting. I think it is more useful in terms of investigation. So this was the entity I was looking at, the cluster, and this cluster has got 4 entities, 101, 2, 3, and 5, which we just saw in the deck like some few minutes back. Okay. What if you want to do an analysis to see what is the reason, how the score was computed? So what we can do is, we can choose one of these entities. Let's say 101 is the entity you want to know that as per the rule defined, which entity this 101 is connected to out of all the data. So we see here is 101 is connected to 103. Now, what is 101? You can click here and you can just quickly query it. And we can also look at 103. So if you see, like, the phone and the address is exactly the same for both, but the name is different. But we take the match score, which was 1, and hence the match score is 1 here. If you want to drill down further into the score, which has defined this relationship, you can do that. So if you see that there are 2 different groups that we configured initially, the name and the address match. And in the name, you can see that we are trying to compare. Anything that you see in yellow is basically highlighting the special characters that we plan to remove. I don't see a Mr. keyword here, otherwise that would also get highlighted, right? So then in the first case, like, we are trying to match the 2 and then creating a score using the Levenstein function, then multiplying with the weight, and this is the weighted score. So you get a complete transparency using this platform, how the entities are compared, what are the scores, what is the weight, what is the final score, and the whole 360-degree around it, right? So it's not really a black box system. It's completely a transparent system which tells you what is going on with your entities. And then, once this execution is done, these results are stored into a table. Then this table can be further leveraged into your downstream process to populate a dimension or fact or whatever, like wherever you want to consume, you can do that. Okay. If you want to look at all the entities that are available, you can create the node, you can click on the node detail. These are all the entities that we went through. Then we can look at the edges. Now, obviously, we will not be having, so ideally, if there are 9 entities and if I was comparing 9 times 9, then there should be 81 edges or links. But we are only retaining the links where there is at least a 50% match. And hence, you don't see like 81 links here, you see only a few. Also, we have the blocking conditions, which means we are not comparing every record to every other record. We are only comparing between USA and Canada individually, right? So again, that kind of further reduces the link. The more links you have, the more data you will have to process and kind of compare. Okay, so that brings me to the end of the entity resolution demo. Let's quickly go back to the slides. Okay, so now the next step is really to have a Q&A. I see that already some of you guys have asked some questions. Let's take them up. I'm going to read the question and then followed by the answer. So the first question is around the scalability of the platform. Okay. So see, in general, it just depends. If you're trying to build your own solution, custom ground up, then obviously you have to take care of all those nuances and your architecture, etc. But the architecture that we define, this is how we have implemented into the platform. So scalability is not an issue at all because we are using Spark as a computing engine, and Spark is a horizontally scaled technology. It's an open source horizontal scale technology. It can scale to like thousands of nodes, right? So depending upon the data volume and how many fields you're trying to compare, we can choose an optimal cluster configuration and and try to meet your SLA. So it's completely an SLA driven decision how many nodes we want to use. But at least with the use of Spark, we have an opportunity. Now, as I mentioned before, we use graph technology as a part of Spark, which is called Spark Graph Frames, and hence that also is executing in Spark. So everything is like parallelizable. Okay. Let's move to the next question. So the next question is about how secure the data is on the platform. How do we handle security? Okay, great question. So from a security perspective, what we do is like, see, let's understand like on the platform architecture. So I'm going to move to the next slide so that it's kind of clear like how this architecture is operating. So this is a platform architecture. If you can see at the bottom, there are various sources, right? We are able to talk to file system, RDBMS, Hadoop, cloud, Kafka, real-time data, whatever, right? And then in the center, the blue box is basically the platform, which with the various modules that I was talking about. What you really want to do is like, like in terms of the security, right? So if you see, the platform doesn't have its own data repository. It's only a metadata repository, right? So the data still belongs to you and it remains in your database. We push the analytics to the data and not bring data to the analytics. Okay, that's the first theory, or that's the first principle, I would say. Now, since we don't bring any data, there is no question about security because we are not storing anything. Now, when we are running the jobs, the Spark job on the cluster is already secure, right? In large organization, they're already using Kerberos as a security, and all the intercommunications happen through SSL. So those communications are also secure over the network. Similarly, when you're trying to visualize any data from our platform, like the user interface, we are using SSL as well, and that kind of secures the data additionally. So the storage is already taken care by the storage technology, whether it is Oracle or Hadoop, in terms of encryption, and then any kind of communication of data happening over the wire is happening through SSL. So that kind of keeps everything secure. Okay. The next question is this available in cloud for trial? Yes, of course. So it's not available as of today, but it is available on demand. So if somebody wants to do a POC or want to assess our platform, we can make it available, we can install it, and we can do a POC, either on-prem or on the cloud. But somewhere in the next month, like during next month in June 2020, we are going to launch the platform in a self-service mode where you'll be able to go to our website, inferyx.com, sign up for a trial, and then quickly run a trial and try all these features out. Okay. There will be some limitations in terms of how much data volume you can process and load, but overall you will be able to get a feel of the platform. Okay, so what we'll do is, like, I made a note. We'll send you the request for sign up, and not just you, but everybody who's on the webinar. And I think that should help you out, right? Okay, so we can take one other question if there is any. Okay, data quality. Okay, so there is one question about data quality, like how do we manage the data quality in the entity resolution process? So as I mentioned before, there could be data quality issues, right? There could be missing values, there could be incorrect values. And to handle that, we have a data quality as a separate module. If you look into this diagram here, we have a module called data quality, which is a component by itself. So you can configure your data quality rules, and once the data lands, the first thing you can run the data quality rules. Based upon the results of the data quality, then you can fix the data or filter the data, and then push the data into the entity resolution process. So if you're using our platform, you are able to pull the data using data ingestion and quality check the data using data quality. And then finally, you can use the entity resolution module to perform the entity resolution. So all these steps can be performed on the unified platform. Okay. Okay, so I think there are no more questions. So I'm going to move to the next slide. So I thank you everyone for coming to the webinar. I hope you all enjoyed and got to learn more about entity resolution and our platform. Here are the contact details. You can send us an email at contact@inferyx.com. You can find us, either on LinkedIn, Twitter, YouTube. Just Google for Inferyx on those websites, and then you should be able to look us up. Also, you can go to our website, which is inferyx.com, and there is a number. This number, you can call us, and we are happy to help you with your entity resolution problems. Okay. So good luck, and thank you everyone once again. It was a pleasure talking to you guys. Having a great weekend. Thank you.